All right, today we're going to do a second day on slope. If you look at the top of your sheet, you see this still says rate of change in slope. Okay, before we get to that, let's do a warm-up problem. It says the rectangles below have the same area. Find the dimensions of each rectangle. How do you find the area of a rectangle? Oh, that's volume. Just length times width. Or base times height, however you want to say it. So what's my length here? And what's my width? So what's 12 times x? How about the other one? What's my length? And what's my width? So I'm going to put the 16 first and then parentheses x minus 2. Is that okay for everybody? What do I know about these areas? They need to be equal to each other. How we doing, folks? How am I going to solve this? Go ahead. You distribute. Multiply that 16 through. Everybody do okay there? Now I got to get my x's together. How are we going to do that? You can either subtract the 16 or subtract the 12. By show of hands, who wants to subtract the 16? 1, 2, 3, 4. Show of hands, who wants to subtract the 12? 1, 2. Looks like I'm subtracting the 16. What does this give me over here? Equals. Notice it's still a negative 32. How do I solve? So x is. Now, did they tell me to find x? Did you have a negative 32 over here or a positive 32? Did you have a positive 4 or a negative 4? Should be a negative 4. Did you subtract the 16 or subtract the 12? Okay, if you subtract the 12, there would be 0 left over here. It'd be 0 equals 4x minus 32. And then you have to add the 32, which will make it positive. Make sense? Okay, folks, again, I ask you, did they ask me to solve for x? What did they ask me for? The area, and they asked me to find the dimensions, right? Dimensions is length times width. So tell me, how long is this rectangle? 12 by, which is, so that one's 12 by 8. You guys know how like pictures, they call them 10 by 12 or 8 by 10s or 5 by 7s, that kind of thing? That's what we have here. What about this one? 16 by 6. Perfect. Do you understand how we got the 6? If the x is 8, I subtract 2 and gives me 6. Perfect. Awesome, right? If I asked you to find the area, what would you tell me the area is? How do you... Okay, length times width. So what is the length times the width? 96. If you multiply those, you get 96 for both of them. And they should both be the same because they told me they had to be the same. Questions on that? All those follow-up questions you should be able to answer once you find that x is 8. Okay. Yeah, slope and rate of change are the same. That's what we learned yesterday. Okay, so rate of change is, what is slope also called? Oh. Still got something else though. Can we play hangman? Pick a steepness. Don't even need the hangman. You saved the man. Okay, also called steepness. Slope is what? And basically all those other things up there that we wrote, correct? Correct? Yeah. Calculating slope. First of all, if you have a graph, you are simply going to count the rise over the run. That was the easy part, right? Counting rise over run. If you don't have a graph, we have a formula. y2 minus y1 over x2 minus x1. That's if we don't have a graph, we're going to use that. And then we found out yesterday that linear slope has to stay the same. If it's a line, the slope has to stay the same, otherwise it's going to be jagged. Okay, so for example, that's a line, right? That's linear, correct? How about this? No, because the slope does not stay the same. It changes. The steepness changes as we go. Good to go? All right, how many things am I asking you for in this first set of problems? So that's how many things? 3 things. I would like to go through and find all of the x-intercepts first. X-intercept is where a graph crosses the what? And if it's crossing the x-axis, what do I know about it? What part of it is 0? The y, which means where's the 0 got to go, first or second? Second, not 1. It is negative 0.5. Y'all see that point right there? Negative 0.5, x-axis. Okay, let's do this. You are correct on that, yes. So we're going to do all my x-intercepts first, though, okay? This is my x-intercept. What do I know about every x-intercept? Which means where does the 0 go? Okay, what is this x-intercept? It is 0, 0. It is the origin. Again, I ask you, for the x-intercept, where does the 0 go? Second spot. My x-intercept is right about there. You want to call it a quarter? I don't think it's quite 0.5. I'm going to call it a quarter, 1/4, or 0.25 obviously is also a quarter. All right, let's go through and let's find all of our y-intercepts. Folks, what do I know about a y-intercept? If the x is 0, where does the 0 go? Okay, and in this one, like Gage told me, it is 1. You guys following okay? Y-intercept, I'm going to put the x is 0, which means where does that 0 go? First, what's the y-intercept? Folks, the origin is both an x-intercept and a y-intercept. It's the only point that is both. One again? Are we following or no? That stuff is not slope. That is stuff that we learned on Monday and Tuesday of this week. Now I'm asking you about slope because it says to find the slope of the line. Now this is the first time you're going to see this from me, but I want to tell you now because we're going to use it in the future. M is the variable that we use for slope. M is the variable we use for slope. Now, do you have a graph so you can count, or do you need to calculate it? I have a graph, don't I? So all I need to do is count. You see the 2 points they put on there for you, correct? Which one do I start at? The leftmost point, which is this one. How many do you have to rise? How many do you have to run? So this is 4 over 2. What is 4 over 2? It is 2. 4 over 2 is just 2. Okay, let's try it again. I'm going to put down M for slope. Which point do I start at? Here's my leftmost point. How many do I need to rise? Run 3. Does 1 over 3 reduce? No, it does not. Could I write it as 0.3 repeating? Remember, slope needs to be a fraction unless it's a word problem. Is this a word problem? All right, slope over here. Whoops. I'm going to start at my leftmost point. That's my leftmost point. 1, 2, 3, but it is down. So did you hear how Gage said negative? And over What is negative 3 over 1? Just negative 3. All right, I think we're good on that. A-okay? Okay, flip it over. We have 9 problems to do, some of which are very similar. In fact, they're all similar to another problem that's on there. So would you agree that the counting ones are super easy? So which of these could I count? Number 1? Okay, so here's number 1. That is your number 1, right? Where am I going to start if I'm going to count this? Which is right here? Where am I going to go? And then? So that would be 2/3. Does 2/3 reduce? No. Which other graph do I have here? Number 3? That would be this one, correct? Does everybody see this one? I don't have a leftmost point. What kind of a line is this? It's vertical, straight up and down. How steep is this? What did I tell you yesterday? It's too steep, right? This is undefined. It is too steep to count. It is undefined. I think I got another graph on there. Is that number 9? Awesome. Which point am I going to start at? Okay, how many do I need to rise? So what do we call that? Negative. How many? 4. How many do I need to run? Does it reduce? No. Got any more graphs? Sure we do. Number 2 is a graph, isn't it? But this is a situational graph, correct? We are burning a candle. Does everybody see that? There's tons and tons of points on this graph, isn't there? We can count this. You can pick any 2 points. I'm just going to choose this one right here, kind of right in the middle. Now, when you look at a situational graph, now pay attention, because this is easy to mess up, but it's super easy to do. You have to make sure your units are actually going by what you think they are. So how many do I have to go down? That's just one box, isn't it? Is this representing 1 unit? Sure it is. How many do I need to run over? Is that actually representing 1 unit? Yeah, so this in fact is 1 over 1, and what is 1 over 1? Oh yeah, there's lots of dots on there. Oh, it went down, didn't it? So it was -1 because we went down. What is -1 over 1? You guys see how that all reduces just down to -1? Now, this is a follow-up question. Follow-up question. My y's are on top when I do y2 minus y1 over x2 minus x1, correct? What are the units on my y's? Inches. Inches per. So this thing, you know, a candle, right? You just saw them at the assembly today. This candle burns at 1 inch per hour. Okay. Now this one, which is number 8, is a little bit different. I think I'm just going to, there are a whole bunch of points on here again. I'm just going to start right here. And I'm supposed to do rise over run, correct? How many do I rise? You rise 80. You see how one line is 80? Okay, so we're rising 80. How many are we running? 2. Does everybody see why that's 2? Okay, so what is 80 over 2? 40. What are my units here? The y's are miles per hour. So just like yesterday, we ain't getting anywhere very fast, right? I think yesterday it was like 38 miles an hour. The dots are actually on all of these right here. That's okay. That's okay. It is a straight line. But those are nice points there. All right. The rest of them are either tables or points, correct? Let's do the points first. I'm on number 7. How do I calculate the slope between 2 points? What's the formula for that? y2. This is the formula that you guys that were absent yesterday missed. And I want you to label your points. This is x1, y1. This is x2, y2. Remember, in your points, the x's come first, the y's come second. X's come first and y's come second. So tell me, what is my y2? Minus, awesome, over x2? Awesome. Everybody following Luke back there? Correct, yep. What do you get when you do your numerator? I ask you, does 15 over 26 reduce? Negative 1/6. You're on a different one? Okay. Check it out, guys, in your calculator. Does it reduce? Because the formula tells me to subtract it. Is that okay? What's that? No, this says negative 10 minus 16. Yep, x2 minus x1. Okay, again, I ask you, does this reduce? No, it doesn't. It stays just like that. And we talked about this yesterday. Does it matter if the negative is in the numerator, in the denominator, or out front? No, I prefer it out front or in the numerator, but it really doesn't matter. And I got one more set of points. Number 5. So we're going to label them x1, y1, x2, y2. I'm now going to write down my formula. Remember that the y's go on top. The common mistake is a flip 'em. All right, go ahead. Negative 18. 4, she tells me on top. Numerator. How about the denominator? 24. What is 4 over 24? That one is 1/6. Calculator will do all that reducing for you. You just got to let it. So then the last two that I have are charts, right? Well, aren't charts just another way to write points? Okay, so I have 1, 2, 3, 4, 5, 6 points to choose from. You only have to pick 2. Okay, which 2 would you like to pick? Okay, so I'm just going to put parentheses around this to make it look like a point. Then I'm going to label it x1, y1, x2, y2. I'm going to write down my formula. y2 minus y1, x2 minus x1. All right, what is my y2? Minus over. Does everybody see where Savannah is getting those numbers from? What is in your numerator? Over, which is? Okay, now follow-up question. What are your units here? Units on the y's are calories per minute. 4 calories burned per minute. That would be if I was asking you if it was linear, because if it was linear, you'd have to check to make sure they all are equal, but I didn't ask you that. Right. And it can be any 2. All right, one more, I believe, yes? Okay, you guys, am I just picking the first 2? Okay. You're going to label them? x1, y1, x2, y2. Formula is y2 minus y1, x2 minus x1. Not over. There we go. 20 minus 10. 4 minus 2. Which is? Tell me the units that would be on this. Per hour. This person charges $5 per hour. Questions? Sure? Okay. Let's get you some homework here.